Hello students, in the previous session we have discussed about fluid pressure. In that we have discussed what is the pressure, what is the fluid pressure, loss of liquid pressure and Pascal's law. Let's discuss about atmospheric pressure and its measurement in this class. Well, you are already aware of what is an atmosphere. The air around us is called atmosphere. The density of air, it varies with the height. As we go on upper side, the density of air decreases. So based on that, pressure also varies. All these things you are already familiar. Let's revise the definition, and this particular year they have introduced the different devices which are used to measure atmospheric pressure. As you know, the atmospheric pressure is a pressure exerted by atmosphere is called as atmospheric pressure. You are already familiar in the class 7th and 8th standard. So particularly speaking, the thrust exerted by column of air in an unit area is called as atmospheric pressure, and on average it is 10 to the power of 5 Newton per meter square. Okay, the value of atmospheric pressure is 10 to the power of 5 Newton per meter square. In the sense, on 1 meter square of area, it acts a 10 to the power of 5 newtons of force. Okay, approximately if we think the human being occupy 2 meter per square area, so the thrust acts on human being is 2 into 10 to the power of 5 newtons. So it always exerts vertically downward direction. That's why we say it as atmospheric pressure. So approximately 2 into 10 to the power of 5 Newton per meter squared of force exerted on each and every human being. But we not feel this atmospheric pressure. Do you know why? So even though this much high value of pressure acts on us, we are not experiencing it because our blood pressure nullifies this atmospheric pressure. So due to our blood pressure, it will be not experienced by us. The value you have to remember, and the unit obviously you have to remember. In our daily life, we can see many demonstrations or examples for atmospheric pressure. Let's consider sucking a water or a juice from a container. Sucking a juice. Sucking a juice from a container. Sometimes thunder coconut or juices we used to suck using the straw. So on the juice it acts atmospheric pressure that lets the juice or thunder coconut juice to let go inside our body. Okay, second one, filling a syringe with a liquid. So if you want to fill a syringe with any medicine or a liquid, so it acts a atmospheric pressure on the liquid. So if we suck it through this, okay, the liquid goes inside this. Okay, next, filling a syringe. Next, filling a fountain pen or or an ink pen. So you are already familiar with the fountain pen, ink pen. In case of fountain pen, if you want to fill the ink to it, we have to put a fountain pen into the ink bottle. So the atmospheric pressure acts on the ink, and there is a sucking force inside the fountain pen. These two forces acts on that, so the ink goes inside the fountain pen. The next example, action of rubber suckers. Rubber suckers are attached to the wall. On the rubber suckers there acts a atmospheric pressure so that it binds with the wall correctly, tightly. Then action of siphon system. Okay, action of siphon system. To bring the water from high tanks to the low side, we can make use of this siphon system. In this case, the atmospheric pressure acts on high can so that the water can come down. The next one is taking oil out from a sealed can. Okay, if you want to take a oil, that can be of any oil, petrol, diesel or any edible oil, from a sealed can, the atmospheric pressure acts through the small hole of the sealed can so that the oil comes out from the sealed can. We have discussed the definition of atmospheric pressure and the unit of atmospheric pressure. Now let's discuss how we can measure atmospheric pressure. As you know, to measure the length, we use the unit that can be a centimeter or a kilometer, and we use the device scale. Similarly, to measure the atmospheric pressure, we need to use barometer. So you have to remember this keyword, barometer. Barometer is an instrument used to measure atmospheric pressure. There are three types of barometers. They are simple barometer, Varin barometer, and anaeroid barometer. There are three types of barometer. You should remember and you have to memorize this: simple barometer, Varin barometer, and anaeroid barometer. Let's discuss about simple barometer. This is the diagrammatic representation of simple barometer. This is a diagrammatic representation of simple barometer. The construction or structure of simple barometer is like this: 100 centimeter long glass tube or 1 meter long glass tube. So you have to remember it should be of 100 centimeter. Yes. We need a trough and we need a mercury. So these are the three things you have to remember as a construction of simple barometer: 100 centimeter long glass tube, trough, and the mercury. The mercury need to fill in the trough. Then we have to fill the glass tube with the mercury. We have to invert the glass tube filled with the mercury into the trough, so that based on the atmospheric pressure, the level of the mercury rises in the glass tube. If the atmospheric pressure increases, the barometric height increases. So here the barometric height need to be considered from the outer surface of the mercury filled in the trough to the level of the mercury raised in the glass tube. This one we say it as barometric height. Based on the atmospheric pressure, the barometric height increases or decreases. If barometer, if atmospheric pressure increases, the level of the mercury rises. So there is an increase in the barometric height. If there is a decrease in the atmospheric pressure, the barometric height decreases, in the sense the level of the mercury comes down in the glass tube. This entire apparatus need to keep it outside to measure the atmospheric pressure. Where exactly we need to measure the atmospheric pressure? We need to keep this simple barometer. In this, we use the liquid mercury because it has more advantages. The main advantage is the density of mercury is more. First thing, it is opaque, and we can easily notice the level of the mercury raised. By using a scale, we can measure the atmospheric pressure. Except mercury, we cannot use any of the liquid like water because it is not suitable. Let's discuss advantages of this simple barometer. Advantages of simple barometer is, it is very simple in the structure. So we need a glass tube, we need a mercury and a probe, that's it. But demerits, if we consider the demerits, there are many. First thing, entire thing, it is kept outside so that it is vulnerable for the air, for the rain, that's why. As far as demerits are concerned, the first one, there is no protection to the operators. For example, if we keep it in the air, okay, the air can destroy the apparatus. If we keep it in the water can mix up with the mercury, the purity of the mercury may change. So, based due to this aspect, there is no protection to the apparatus. The scientists have to think for other type of barometer, that is 14th barometer. In this, operators have kept inside the brass scale and the mercury is filled in the leather cup. Okay, here two things you have to remember: brass case and leather cup. So these two are used to give the protection to the operators. The vernier scale is attached so that to give the accuracy in the reading. Even thermometer can be put to measure the temperature with the atmospheric pressure. Whenever we need to measure the atmospheric pressure, we have to raise you have to initialize so that the atmospheric pressure acts on the mercury. Based on the atmospheric pressure, the level of the mercury rises in the 14th barometer. Based on the barometric height, we can easily measure the atmospheric pressure. Well, observe the aneroid barometer structure. Here we have a box. The box B is attached with a diaphragm. Here the diaphragm, it is very sensitive material. If there is any changes in the atmospheric pressure, then the diaphragm goes inside. The diaphragm goes inside. When the diaphragm goes inside, the rod attached with the diaphragm also go inside. So the wheel attached to the rod moves anti-clockwise. Moves clockwise, so that it shows increase in the atmospheric pressure. If atmospheric pressure decreases, the diaphragm comes up, so that the rod attached to diaphragm goes up, so that the wheel attached to the rod turns anti-clockwise. So the pointer comes this side, shows decrease in the atmospheric pressure. Compared to the simple barometer and 14th barometer, this is the best because it can keep anywhere we want. This can be keep it in oceans, this can be keep it in the lands, this can be keep it in the forest, because the liquid is not used and the operators are well protected. And this is the model of a aneroid barometer. This is the model of a aneroid barometer. If pressure acts on this, the pointer shows the respective change in the atmospheric pressure. In this case, you have to remember two things. One is the construction and one more is the work. In the exam, it may ask for 2 to 3 marks. You have to remember the parts of it, how they are organized and how it works. In today's class, we have discussed about what is atmospheric pressure, what is the unit of atmospheric pressure, value of atmospheric pressure, and the devices used to measure atmospheric pressure. In the next class, using atmospheric pressure, how we can do weather forecasting, that we are going to discuss. Thank you.